Hi everyone. I wanted to give you a revised tutorial for processing the data in experiment 8. I think probably one of the most relevant things to think about for processing data in experiment 8 is actually what we did in experiment 7, because they're all interconnected. So in experiment 8, what we did was we did protein assays and enzyme assays of every fraction that we collected from the chromatography we did in experiment 7. So we need to keep that all in mind and probably need to process that data. So we want to determine sort of the overall enzyme activity, and we also want to determine the protein concentration, and then we're going to plot them and put them on the same graph so that we have an idea of which fraction to use for experiment 9 to do all the enzyme kinetics. And that's where this all fits in. It's to be able to set up to do the optimal fraction for experiment number 9, which will be the last experiment we do. And we're going to do that experiment twice or maybe 3 times to be able to reproduce that data. So let's go ahead and look at this. First things that I would do is I always, and people have seen this before, I've color coded things in the past. I use colors to be able to distinguish things, but spreadsheets, if you look at this, it's a whole bunch of numbers. But if you go ahead and start like here, the first 5 are dilutions of that fraction that was the extract from the yeast cells. So let's go ahead and make that a light yellow color. Then what we did was we took the remaining part of that extract, all of that 200 microliters, and we added that to the column, and then we added some buffer to that to load the column. And in this case, I'm looking at this data set, the only 2 fractions of the sort of the quote, the load we did, where they were good, were valid, were these 2. So let's make that a slightly darker yellow. Then we collected all of 0.1, of the wash 0.1, 0.3, and 0.6 molar, and that's all these fractions, and we'll make that a dark yellow. Let's go ahead and do the mutant fraction, because this is the wild type, and this is the mutant fraction. The first 5 were that dilution of that extract. The next 2 we'll make that a darker blue because that's the 2 load fractions, and then this 20 samples right here are all going to be the wash, the 0.1, 0.3, and 0.6 molar elution. So we've color coded all those. And just to add a principle, I always will color the standards as well, and I'll make them bright yellow because P&P is a bright yellow color, so I decided to put that in there. So what we need to do is see what the standard curve look like, and that's what I always do first. And the top fraction was 250 micromolar, and from there we did a twofold standard serial dilution. So let's go ahead and put equals this value divided by 2, and we have that. So let's go ahead and copy that down across there so we have those concentrations. Now, let's go ahead and do the averages of these 2 values. Remember, we did the standard curve is the only thing we did in duplicate. And we go ahead and put equals average and put these 2 values in. Hit enter. So that's the average, and then they go ahead and calculate it all the way across. You just copy all the way across. So here we go. We can actually do a standard curve by copying these like this. Go to Insert, Charts, this chart value, and we see here, and we look, and it looks pretty linear. Let's go ahead and add a trend line by just right-clicking on there and display the equation and the R squared on the chart. And let's tell it to go away. And we see it's a very good R squared. It's virtually 1. And we have a slope of 0.117, an intercept of 0.633. So we know those values. It looks good. So let's go ahead and determine the intercept and the slope of that line. Because I like to go ahead and use those fixed calculations because I find it a little bit easier, but sometimes you need to use it multiple times. So it's a habit of mine. Equals intercept. And the intercept, if you remember how intercept works, it's all the known y's, which are these values. Then you put a comma in, and then you put the known x's in. This seems odd, but this is the way it works. And always look here, 0.06, 0.06, those numbers are the same. And the slope, let's go ahead and calculate the slope, equals slope. And it goes the same way. You enter the y's first, a comma, and enter the x's and hit enter. And there it is. It's the same number. That's good. So I always put the equation on the chart because it makes sure that I've highlighted everything properly and have done things consistently. If they wind up varying, I know that I may have made an error somewhere. So this is one of the ways that I proofread what I've done. Now, one of the other things we did during this experiment is we went ahead and named things in a particular way that fits the way I would name things. At least this is the way I name things. We had the first sample was called, I called load. And the first one was 1. And the second one, which I can just go across here, it'll automatically count, was load 2. Then I go ahead and put the wash 1, and I know that I need to go that for 5. And notice here it tells you that you're doing it to be wash 5. 0.1-1, make that go to 5. 0.3-1, make that go to 5. And then 0.6-1, and we go ahead and do that. We have that go all the way to 5 as well. So we have all those done. Let's go ahead and calculate how much product was made in that length of time. And we're going to see that I'm not going to write it down because I told you to let it develop into a certain point, so I hope you would record that time. But let's go ahead and do that. Here we have wild type PNP absorbances. I always put ABS. What I do here is put an equal sign. I'm going to line them all up to make calculations easier. Hit that, and I just drag that across, and it copies those two values, you see. Next one is put an equal sign in this value, hit enter, and drag all the way across to 0.1, the fifth fraction. Now we go ahead and do the next one, which is this value, hit enter, and then we drag this one all the way across. So what we've done now is we've taken all these absorbances and created one little line so we can easily do calculations by just doing copies. And that's the easy way to do it. So here it's wild type, and here we're going to determine the concentration of PNP. Okay. Now, since it's Beer's law, we know that that is going to be as y is equal to mx plus b, and we're going to solve for x. So x is going to equal y minus b divided by the slope. So let's do that. It's equal to the quantity. So we want to make sure the subtraction gets done first. So it's y minus the intercept. And remember, we're going to be using this intercept over and over again, and we want the same number to be used, so we need to fix it in place. So I'll put the dollar signs in front of it. Close off the parentheses. Then divide by the slope, which is this value right here. And to fix it in place, we need to put the dollar signs in again. Whoops. Whoops. Make sure you do it right. Hit the little green check mark, and then we do that calculation. So we fixed everything in place. We can copy all the way across and do all those calculations pretty quickly. Now, and what I'll do now is have all those calculated, and I'm going to color them. the yellow color. So we know that these are the calculated values. And that's how I like to do it. I put things in color that I know that I'm going to need to go back to. So let's go ahead and do the mutant now. We'll go ahead and label the same way. Here, we'll go ahead and put an equal sign, put that value in. Go over this way, copy that in, equals this value, hit enter. Drag that all the way over to 0.15, and then put an equal sign here. Click that value, hit enter, and then drag that all the way over to here. Now we need to do mutant, and it's going to be the PNP concentration. Okay? So let's go ahead and do that. It's that same equation again. It's going to be y minus b divided by the slope. So let's go ahead and do that. Equals this value minus the intercept. And we need to fix that in place again. So let's go ahead and put the dollar signs in. Dollar sign, close the parentheses, slash, divide by the slope, fix that in place as well. So that's a dollar sign there and a dollar sign here. Hit the check mark to make sure you save all those. Then we'll drag that all the way across. And just so we know where it is and what it is, these are calculated values. I color them blue. At this point, I'm always kind of interested to see how things look. And what I'm going to do is I'm going to draw a preliminary graph. And actually, you'll see how I will just modify that graph as we go. So here it goes. We'll go ahead and highlight this entire area, all the X's, and then I will hold the control down and do all of the Y's. Okay? And as a deviation from what we've done in the past, it's going to be insert, and then we're going to use this feature here because this is not going to be an XY scatter because the X's aren't meaningful. They're just categorized. So they're just like fraction numbers. So we just go ahead and use this value right here and use that form. And we have a graph that looks like this. Okay, let's go ahead and just change that title to concentration of PNP and put WT for wild type. Well, let's go ahead and spell it out. And we see here, there's a couple of values. These kind of washed off from the load. And here is the product we load. And that's about where I kind of expect it to be. Let's go ahead and put that down here. Now let's go ahead and repeat it and look at the same thing for the mutant. So let's go ahead and do the mutant again. So just click here, highlight across there, all the way across all these X values. And now we'll highlight all of the Y values. And go to Insert. And then the graph is this one right here. You see a very similar graph. The same thing happened, except maybe there's a little bit more protein here and a little bit came out into the wash. But let's go ahead and click on that title and put concentration of PNP for the mutant. So we have these two values. So we have these two graphs. And this is half of the data that you need to be able to do experiment 9. In fact, this is the biggest part of the data we need for experiment 9. But I also want you to use the protein data and compare that. And we've completely ignored that up to this point. But I'll go ahead and I'll stop this video here, and we're going to go to, we'll create a second video where we do the protein and then the final graphs. Okay, I will see you momentarily. Bye.